Alright, yeah, so we're going to be starting our next unit, which is Pythagorean Theorem, alright? So Pythagorean Theorem is spelled Pythagorean Theorem. Alright, so the Pythagorean Theorem is for helps us find the different side lengths of right triangles. The Pythagorean Theorem only works with right triangles. So only with right triangles, alright? So what exactly does a right triangle look like, right? So a right triangle is a triangle that has a 90-degree angle. So the way that I remember it is the triangles that make a perfect corner, or the triangles that have the little square in the corner. It's a right triangle, all right? So the Pythagorean theorem only works with right triangles, and it helps us to figure out the side lengths of each of the sides of the right triangle, all right? So the Pythagorean theorem has its own formula. It's very, very simple. It's a squared plus b squared equals c squared. Make sure you get that down, and then we're going to talk about what exactly does a represent, b represent, and c, all right? All right, so let's go ahead and erase that. I should have gotten an eraser, but that's fine. Alrighty, so we had the formula a squared plus b squared equals c squared. Now we're going to draw a right triangle so that we can figure out what exactly does a, b, and c represent, alright? So on a right triangle, this is called a leg, this is a leg, and this side is called the hypotenuse. I know you may not be able to pronounce that. You can say the hypo, you can say hippopotamus. I don't care what you say, as long as you know that the hypotenuse is always the diagonal side, and it's basically the side across from the right angle. Please remember that, because sometimes they'll try to trick you and they'll flip the right triangle other ways. Just know that it is the diagonal, or it's just basically the one across from the right angle, all right? So this is a leg, hypotenuse, all right? So looking back at our formula, a is always a leg, so this is a leg. B is always a leg. C is always, so let's put always, the hypotenuse. All right, so you have a leg squared plus another leg squared equals the hypotenuse squared. So if I take this side length and I square it, and I basically add it to this leg squared, it should give me this side length squared, all right? I know right now it may seem a bit tricky, but I promise you this is probably the easiest thing that you will learn this year. As long as you're able to do squaring and square roots, you'll be perfectly fine, all right? So let's get some examples. All right, so let's draw a triangle, all right? All right, so let's say, hey, we know that this side length is 5 and this side length is 3. We want to know, hey, what is C? What is our hypotenuse? What is the length of our hypotenuse? So whenever you see a right triangle like this and you're solving for the missing side, you always want to start with Pythagorean theorem, all right? So you know that our formula is a squared. So we can do a squared plus b squared equals c squared, right? So let's figure out, what do we know? So we know that C is always the diagonal, so it's always the side across from the right angle. So we know for a fact that that's what we're looking for. So we're looking for C. C is always the hypotenuse. So now, do we know A and B? Remember, A and B is just those legs. So yes, we know A, and yes, we know B. It doesn't really matter which one. This can be A, that can be A. It doesn't really matter as long as you're plugging in the legs and not the hypotenuse, all right? So let's go ahead and plug that in. So instead of writing A, we're just going to use 5. So let's do 5 squared plus, we're going to use 3 plus 3 squared equals C squared. So now we can go ahead and try to solve this so that we can get the length of our missing side. So we know 5 squared, whenever we say square a number, it's basically saying that number times itself. So 5 times 5 is 25 plus 3 times 3, which is 9, should give us C squared, right? So 25 plus 9 is 34. 34 equals C squared. Now we have to ask ourselves, how do we get rid of this square? What is the opposite of squaring a number? You guys may not understand, but I promise you it'll make more sense. So what's the opposite of squaring a number? The opposite of squaring a number is square rooting a number. So to find C, I'll have to figure out what is the square root of 34. And you guys should know how to do this. This is our first unit. So remember, the square root of 34 is between 5 and 6. So that 25 and that 36, we know it's closer to 6. So my answer should be about 5.8. So this is basically saying this side length is 5.8, all right? If you want to work backwards, you can. 5.8 squared gives you 34. That's why the way that we take off a square root is by doing the opposite, which is squaring, all right? And that is your final answer. It's very simple as long as you know that C is always the diagonal and you can go from there. It's pretty straightforward, all right? We're going to work one more example, all right? 2 more examples, all right? Just 2 more. All right, let's draw another triangle. This is a right triangle, but remember I told you that they can flip it and try to trick you up, all right? So let's say we know this side is, let's do 12. We know, wait, let's say this side is 5 and this side is 12. We want to find this side, all right? So remember, what do we have? What do we know? Do we know our legs? Do we know our hypotenuse? What do we know? All right, so yes, we know both of our legs. Remember, our C, our hypotenuse, is always that diagonal one, so we do not know C. So that is what we're solving for. So let's do A squared plus B squared is equal to C squared, and we're solving for that one, all right? So we can say A is 5, so 5 squared plus 12 squared equals C squared, all right? 5 squared is 25 plus 12 squared, which is 144, equals C squared. Once you add those together, you should get 169 equals C squared. Remember that the way that you take away a square is to square root it. So the square root of 169 will give us C. And we know the square root of 169 is just 13. So C is 13. So this side length is 13 because we just figured it out, all right? Now we're going to do another one where it gives you the C. It gives you the C, but it doesn't give you either A or B. So let's try that. Matter of fact, we can actually use that same example. Let's use that example. And let's change up the numbers. Let's say that they put 13 here, but then we want to find this side. So we know, hey, we have one leg and we also have the hypotenuse. So now we want to figure out what's this other leg that's missing on the side. So you still start with the same formula. So A squared plus B squared equals C squared. We know what C is. C is always that diagonal. So we know that C is going to be 13. So I'll put 13 squared here. And then remember I told you the leg, it doesn't matter if you put it for A or B. For this one, we're just going to put it as B, all right? So then we have B, which we'll say is 5. And then now we're looking for A. What is A, all right? So now we have A squared, whatever that is, plus 5 squared equals that 13 squared. So now we're going to try to solve this. I know it may look kind of tricky, but I promise it's easy, all right? So now we have A squared plus 25 equals 169. This is basically an equation. What you do to one side, you do to the other, and then just basically your opposite operations. So the opposite of adding 25 is what? Subtracting 25. So I'll subtract 25 from both sides. I'll be left with A squared is equal to 144. To take off that square root, I need to square it. So I know A equals 12, because 12 is the square root of 144. So A equals 12. So it's pretty simple. If you know the legs, you just add them. If you know just one leg and one hypotenuse, it's just subtraction, all right? It's pretty simple, but we'll continue to work on it. If you need more examples, please just let me know. Don't hesitate to come and see me.